So just to talk Eclipse here. I know Mark is saying you have a hangout later on with Mike Helmick and a few others, so I'm not going to get too much into the image processing. I'll leave that with you guys for later on. But this, what I'm going to present, will definitely back up what I'm sure Mike and your group will be talking about later with the Photoshop and the imaging, trying to bring out a moon in the image is the main key that we've been trying to work on. So what I did was I went and made a model of an eclipse. This is a 3D screenshot. So this is in Blender, I made a model, put a solid object in the model, put you know, the light source behind it, put in the atmospheric particulate matter to the right ratios and densities of air, and with the right anisotropic properties of light coming through an air medium, and hit it with the light to simulate the sun, which is at, this is to scale, so it's at, you know, 1.5 million lumens, and the distances are correct, to try and simulate an eclipse. And what the model renders, as you can see, you would expect to see a crescent around the actual object itself as it enters into totality, which no one saw or observed in reality. And then I went to the next phase to say, okay, well, how would the light distribution work within that type of anisotropic particle system? So as light hits a solid object, you would expect to see the same crescent with a little bit of backscatter lighting around it. As the light comes around a solid object, you would get a rendering of the entire orb, i.e., if it is the moon or a solid object, in the field, in the camera lens with the filter on, right? And you should see a bouncing effect off of the front face, the leading edge. As the light hits the object, it bounces out radially, right? So that's what all these lines are in the blue spectrum, because it goes to red and then slows down as it reflects it, it polarizes. So all reflecting light polarizes and heads backwards and creates this effect on the other side. And then the non-polarized light comes around the other side and creates these halos, which is what we see normally, you know, moon halos, sun halos, rainbows, etc. So that's actually what light is supposed to do. And then for a comparison, so this is my control, right? This is what it should look like. And for comparison, I took some moon shots from some friends of mine, really excellent photos. Did the same process on it, didn't change the settings. I just changed the process, just changed the photo, used the same settings for the analysis. And a moon shot would transpose to this. So you'll see this is the crescent at the front, now brought forward, and you can still see that there is a moon object in the background. This is like backscatter light. And then I compared that to, let's see, this image here. This is during the eclipse as it approached totality. And what I found the most fascinating about this is you get the red split spectrum that appears in the sensors of the cameras, which isn't that unusual. You see refraction and lens flaring that kind of splits the image in the red spectrum. But what was fascinating was this thing here, being that it's an inverse image of this side of the object coming around and being inverted backwards and being forward projected. So it's being forward projected to you as the observer on the ground to a centralized focal point. So it's this thing, whatever it is, whatever the light's coming through, being refracted and being projected like a lens to you at the ground and appearing in front of you. And you can kind of see, if I zoom in a little bit on this image. Oops, go back one, right there. So this is the actual object being refracted, and there's a whole bunch of little tiny ghost ones in the air. Right, you can kind of see them being split out in the air. And what happened during the eclipse, well, I'll show you how that analyzes actually first. So what I analyzed was I took it to this spectrum gradient to take out some of the red and bring the black forward, right? So I could, you know, wash out all the interfering light patterns to see what I could see. And it renders out to this here. And there's some interesting things in this picture. So here's that object again being forward projected. There is something a little bit of a dot up here that appears to be a physical object of some kind. And then this gradient shows the edge of whatever is causing the eclipse. It cannot be seen, so it's actually not visible. Because when I take it to the other spectrum, like I did with the moon and my control, there's nothing there, right? Absolutely nothing. Except you can see that something is causing the magnetic field, which is, light traveling through the field is photons, and photons have magnetic fields. So, magnets can bend light as they travel through. They become polarized. You can see that this is the focus point, and those little half moons do kind of sort of appear in the gradient. But whatever's causing the eclipse is completely absent. There's nothing there. And so what I went to the next phase of the analysis to see, well, what can I see if I invert that to a negative and amplify it? So I did that to try and find out what was there, if anything. And then what I found was, well, there's the light, because it's intense, so it comes out just as a gray wash because this is a negative. And whatever is supposed to be there is not there, but you can see that it is having an effect on the light scatter in the negative field. And whatever is coming through that object down to create this half moon is causing a bending of the light being forward projected down here. So the angle's coming through from the top right down through the object, appearing here to be forward projected to the center of frame, and then scattering in the background below it in the left. So that tells me there's an electromagnetic cause. There's an electromagnetic force that is causing this to happen in that gradient. And I did it in 2 different gradients just to amplify it to see what's really happening here.
Well, that's pretty amazing.
Yeah, it is. Yeah. So then the next thing is, okay, well, what's causing that, right? And the typical NASA response in their videos online and the mainstream media is that what we're seeing, that blue object, if I go back here, this blue object here is coming down through the atmosphere plane above our heads, through our air and everything else. And it's being forward projected and causing all these little moons on the ground by the millions. People took thousands of pictures of these. Sometimes, depending on if you were north of the equator or south of the equator, they would appear upside down. Or if you were north of the equator, they appeared the other way, right? With the crescent facing up, and they were being inverted as a shadow. So this is like the same image being rendered as white light on the ground, because it's going through the blue into the white, and spectrum change. So then I said, well, where is that actually happening, and what's causing it? And I looked at some high altitude footage at 75,000 feet with the 360 camera. And that's what the eclipse looked like at 75,000 feet through a 360 camera.
Wow.
And there's all those little orbs again. I was like, wow, right? Like literally, wow, there's the orbs. And you can see that, there could be a little bit of frosting or ice or whatever on the lens camera, but it's at altitude, right? So it's cold up there, 75,000 feet. But that doesn't say that that's the cause. What that tells me is the angle of light that's being projected to the lens, because you're getting an unequal distribution of light scatter. Some are over here. This one's being illuminated more than this one. This one's a full dead-on center. So this means the light's coming almost perfectly to the center of the lens as it looks out through the medium. You're getting a really nice rendering of the image. So that tells me that's a multiple diffraction pattern, right? It's coming from all angles in a like your perspective, right? Your degrees of your perspective coming at all angles into a center point. So it's multiple diffraction, right? There's no way of getting around that. So millions of these diffraction angles are now being projected down onto the cat. And it's not just cats, it's dogs too. There's a dog, right? So we're going to be fair. The dogs got it too, yeah. It's raining cats and dogs. Yeah. So
raining moons on cats.
Raining moons on cats and dogs, yeah, exactly. So we've all most of us have seen that video where it was particularly NASA was trying to explain that, oh, that's just a pinhole effect where the light comes through the trees and causes the trees to act like pinhole cameras, and you get multiple projections on the ground. Well, being an artist and painter, I mean, that's another one of my hobbies. I do music, art, and paint. I know how pinhole cameras work, right? And what a pinhole camera will do is you can take a pinhole camera light, and what it does, it'll actually invert the image, but it projects the entire field of view, right, through a pinhole, and replicates the entire image on a background, right? It is true that pinhole cameras will work, but pinhole cameras will not split multiple images into multiple refractions unless it's coming from multiple angles. You see what I mean? You'd have to have a million holes in this type of screen, or on that mirror. This one's actually being projected through a pinhole and reflected off and bouncing in the room. But you'd have to have millions of holes in it, and each image coming from a different angle in order to get multiple images of the same thing from all different angles, like a three-dimensional effect. And that's what that is on the ground, is a three-dimensional scattering. Right? It's coming from all angles, every direction, multiple intensities. So there's no way to say that that is a pinhole camera effect. And we have to reverse that in our minds. So here I'll show you something here with the moon here. To be fair, we'll compare a picture of this image I showed you before with that orb thing, compared to a moon that Judith sent me. This is one of Judith's pictures. And she had sent me, and she said, here's the red. So the red is normal, right? And this green here, greenish area, if I was to invert that and do the same thing, you would see that, well, that's this just being reversed, right? That's normal. Light bouncing, there's the orb. But in this case, there is nothing here, and it's being forward projected through a lens, right? That's the only way. That's the comparison. The moon will scatter it and cause a flash image or a flare of itself. And this is completely different. So it's not the same thing. So then I concluded that, let me see what else is going on. One of the best explanations I could come up with in a model to say, how is that happening, is this image here. So I took it into a model. I made an orb. This is a plasma field of UV light. This is a solid object in a 3D model. So the light scatters everywhere within the model itself. So it's just like a square, but the light source scatters everywhere. So it's going in all directions. But since the source is localized to a projected point, as the light bounces around in the field, the particles go through the orb and go back to the source. So that creates a shadow. So if you imagine that you were standing inside of this orb looking back towards the sun, you would actually be seeing your own shadow, canceling out the light that's trying to reach you, because now it's going back just as fast as it is trying to come towards you. It's your own shadow, in essence, traveling backwards. That's one of the processes I'm trying to understand, see how that works. Then I simulated in a model the same setup. So I took a light, a very intense light, 1,000,000 lumens. This is a solid, right here is a solid moon simulated object, or something to interfere. It's a sphere to interfere with the light. And then this area here is a simulated dome lens to give it something to appear on and focus on. And then this field underneath here is a particle field. So it's a semi-transparent particle field to simulate the atmosphere. So it hits that, bounces through, creates the half moon through the air, and bounces on the ground to create the half moon over here. So that was my first attempt to say what can be causing this. So you can see that in this rendering, in this model setup, it's just a projection, like a standard projection at a movie theater type of idea. So it's backlit. This would be like, what was his name that did the one with the monkeys, you know, the Space 2001. Yeah, Stanley Kubrick came up with this back projection type of thing, right? So the whole NASA thing. But anyway, that's kind of like what they use. But you can see you only get one rendering of the image, and as it travels through the lens, hits the air, travels to the ground, it expands to create, you know, what would be a shadow on the ground or illuminated crescent. It's not making millions of them, right? It's only making one. And no matter where you move the light source, you're only going to get one image projecting forward through that type of lens. So that tells me that in order to make this happen, you need millions of lenses, individual crystals, and the light has to be traveling down the center of a crystal to be projected like a hologram or like a laser. Like when you do a laser, you send the light through a crystal, make a perfect laser, focus the light, and then it hits the ground like a laser beam from many, many angles, all at the same time. Eclipse, without an object being there, the best explanation I could come up with for that so far is electromagnetic interference. So the light is there, but whatever that object is a black body radiation absorber that has an intense electromagnetic field, enough so that it'll allow some light to pass through its periphery surface because it must have a boundary layer to have a charge, but it's so negatively charged on the inside, it absorbs everything that comes into it and lets very little of it come out. What does come out comes out in the blue spectrum, and what is inside of it is absorbing all the light and just making a black hole. It's like literally a black magnetic hole. Nothing comes out of it. So I took that idea and I took this image of the eclipse sent to me by a friend and started to say, okay, the light scattering from around the outside is following a magnetic pattern. This is just a magnetic toroid. So I'm trying to visualize that in 3 dimensions to either rule out that it is an electromagnetic orb object or a planetary object that's above the dome and interfering with the light path trying to reach the surface and just canceling it all out. And it has some interesting ramifications too. What happens, you know, the NASA thing where it's a forward projected image on the ground makes absolutely no sense. Because if I showed you that picture of the moon here again, I'll scroll up here. There's the moon, and we should see that if that's actually reality, and as light passes through trees, right, then every crescent moon and every moon phase would come through the trees at night, and you would see animals in the forest that look like this, right? They would adapt, right, to be camouflaged, right? You know, every bird that flew over the sky as the moonlight came down, or the sunlight came down, would be projected as a secondary image on the ground, and you'd have, you know, one bird would appear like an entire flock on the ground, and every animal predator be running around chasing ghosts that don't exist, right? So if your mind is going to accept that forward projection thing of NASA and pinhole cameras, I'm just suggesting you think again, right?
Can I ask you something, Chris? Is this only happening at the eclipse, or does those pictures with the shadows of the moon, or can that happen at any time, or is this just in the eclipse?
This is just during the eclipse. See, and that's what makes me ugly, is because I think it was either Time or Now This did the NASA video, and it actually says in that NASA video that this happens normally all the time. Sunlight or light, this is a normal process. Well, that's a complete and utter nonsense. It's not a normal process. It only happens during eclipses. Like I said, otherwise the moon would do it every day, right, through the forest and the trees, and the sun would do that every day. If something passed between it and a, you know, pinhole camera in a tree, and there was a bird sitting in the tree, well, then you would see 1,000 birds on the ground, right? It doesn't happen, right? And it just blows my mind why that is. Yeah. But the long story short, if I can bring up some other, you know,
can I just say, in the chat room, DITRH, Dave, down the rabbit hole, Dave, he asked if you would show your tree with the apples in it.
The tree, yeah. So clearly what's going on to me is that we are, you know, on the plane of inertia, right? We experience in this center point where the two negatives and positive come together and balance in a neutral. We experience a slightly biased system that's slightly biased towards the positive. So it keeps us down, right? We experience that as gravity. we're on the plane of inertia in the center of a magnetic field, toroidal, like a double toroidal field. All the light that's outside of it is coming through the firmament. You could call it the firmament, the dome, which could be, I don't know what it's constructed of. It's, you know, like molten, liquid molten glass that keeps everything from, you know, keeps us safe. It creates a dome so that we have pressure in the system. You can't have an open system to vacuum and still maintain pressure, right? It just doesn't work. So you have to have something to contain the pressure that we experience as atmospheric pressure of 14.6 psi, whatever the number is. It's around 14 psi, right? And that's the only way that would work. And we're on this inertial plane, and this is like the tree up the center cone, right? The tree of life, the whole 9 yards. It's right there, and it goes in both directions. There's a negative and a positive. We just happen to be on the positive side of it, right? Which gives us the sense of gravity, but it's also neutrally negative. Like our bones are made of dielectrics, calcium. You know, our bodies are made of water. We have salt in our bodies. We have some iron in our bodies. So if the iron flows in the positive direction, it allows our blood to flow. The dielectrics and the negative side of it in our bones is actually what's holding us up. So it's the bottom side, the negative, that's actually allowing us to stand, because it's actually levitating us to a certain degree, helping our bones, which are calcium, float in a magnetic field. So that's the basic construct, and we're in the center of it. So then I got looking at the electrical side of it and studying the moon. Since we're talking the moon and the eclipses here, a friend of mine, Brad Gillen, he sent me these pictures, and what we did was oversaturated them just to bring out some of the colors of the image we were seeing. And the images in the color phase lines up with anodizing of titanium and other rare alloys. So the charge that causes the craters, which are all at 90 degrees to the surface, so nothing comes in at an angle, they're all sparked and arced to the surface to cause the craters on the moon. You can actually see the approximate voltage required at each point if you do it in a color spectrum, right? So as color changes, the more you saturate it, the deeper the color. So the golds are at about 50 volts, a million amps, whatever it was, right? High amperage, right? Low volt, high amperage, and just went bang and creates this crater, right? Some of them are negative, some of them are positive. The ones that have a raised center would be, the inverse of the ones that don't, right? It's just an inverse polarity. And you can call out some of the people that are trying to post images like this one here and superimpose the moon over front. I'm sure Dave or Mike will probably talk about that when he meets up there, but so I won't get into that too much, but that's what it really looks like in reality. So let's see. The next thing is kind of some evidence of that is, in order to have a multiple diffraction, right, of it coming through a lens and getting more than one image on the ground, you have to have the object between, and the lens is between, the object is actually between the light source and the lens, and it just diffracts into multiple images. And here's another image. Now this person got a cool image. This came, Monique Chenard from Moncton here. She sent me a video, a link to a fellow that actually was talking about the Moon Group and asked me to get another video and to take a look at this. So I grabbed a screenshot just to discuss with everybody. My initial thoughts on this was that this is an image of the eclipse in progress. And you can see that this is the sun and this is the occulting object. It's being refracted in the red spectrum. There's a bit of a duplication of this image in the center of this green orb here. So there's a duplication of it in red. You can kind of see it's very, very faint if I zoom in there. Sorry for the phone ringing there in the background. So there it is again. It's kind of like purpley pink here now. So that's just this image duplicated. And because of that, you can deduce. You say, okay, well, if this image is being duplicated slightly as a doubling effect, so that's a double image. then this green image is a double image of this red image. And if I was to take that out and do some color spectrum, if I had the original image, you could probably do that. And you would say that this Ankh type shape with the polarized plasma bouncing around inside whatever that is, it's like a plasma ball, you know, the ones you put your hands on, right? Static charge, the plasma's on the inside, you touch it on the outside, and these lightning bolts, you know, dance around the glass, right? That's, to me, that's my first instinct, is that's exactly what that looks like, right? So I'm leaning towards some sort of a, outside of the dome, there's another object that the light's passing through, canceling out the sun and projecting it forward. And it looks to be spherical of some kind, or some kind of a lens. And yeah, it's like the Ankh, eh? That's the Egyptian Ankh type of shape. That just kind of blew my mind when I saw that. So I'm looking into that one with some more detail. But the main rub here is that the system and the plane that we're on in this reality, like looking at all of this evidence and the eclipses and everything else, is that the whole secret of the system is a dielectric neutral on the bottom, which goes back to that, the tree shape there, the double toroid. So we have the negative and the positive on the bottom, and the circuit, like we've gone through all those circuits of the ancient history with the cities being destroyed and the craters in the ground and all the destruction in the history and everything, is basically this. It's the earth and the oceans are a dielectric, and of course it has positive and negative, you know, iron mountains versus, you know, salt mountains and everything else. It's obviously well distributed, but it has a bias to the negative dielectric. And then the positive is on the outside in a Gaussian sphere, like under the dome. The dome would have its own charge, capacitance. Essentially, it's a giant capacitor. The dome itself is the outside boundary. And then the Earth center is a neutral. And it's just a positive and negative dielectric dance in the middle. And if you had an air gap, right, to the ground and the air, and then plug that into the water, you've got the circuit that Tesla had in Tesla's tower. Right, it's exactly the same circuit with a coil on the top, a pipe into the ground, tapping into the water, and the ground circuit, and then an air gap in the vacuum in between, and the coil takes it off as a charge. And that's exactly what Tesla was doing, and I think that's why J.P. Morgan and all the rest squashed and confiscated and hid all of his work, amongst others. I mean, every time someone tries to come to the surface and bring this forward, it just gets squashed, because I think, one, you have to treat it with a lot of respect, because if you don't do it right, you know, you could be bringing down whatever it is above our heads onto our heads if you don't control it properly. And two, it's a free energy circuit. I mean, it's an unfathomably huge, never-ending free energy source, right? It's easily tapped into. It's just three-phase power with a vacuum gap. But, you know, you'd have to regulate and treat it with respect, obviously, and you don't want any Joe Blow out there trying to tap into the sky, because it's a dangerous source. And that's the thing, that, you know, they don't want that information coming out, whoever they are, you know, the ones, the powers that be, that want to control the energy and the oil and the power and everything else. It is really that simple. It's that simple a circuit. Just to go back to the eclipse thing, I did a little bit of an analysis here on some eclipse photos. What I did with this one is pretty much the same phase that I showed you before, where it's, you know, partial eclipse, and the object you can't see it, but the object would be in this zone here, and I'm zooming into just the edge of the object, right at the edge of wherever that arch is. And when I zoomed in on it, right, you can see that, yeah, it looks like there's craters there. Right, there's some craters and, you know, some backscatter light inside the black spot, right, just at the edge. And I zoomed in on that and tried to get some images of it to see what it was. Different ideas. So that was interesting in itself. But then what I also did was I checked the other side of it. Right, you have to check the other. You know, if you're going to be looking at it, you got to check both where the image is being occulted and what's being scattered on this side. So this would be, in theory, on the other side of the sun. and you get the same images appearing in this field as you do over in this field. So it's the same thing on both sides, whether it's on the black side or the red side or the lit side. It's the same type of effect. So it's just backscatter, photon radiation that you're catching in the lens. So it doesn't indicate that there's any moon there at all or any object, because you get the same thing either way. It doesn't matter. There's no evidence that that is actually the moon. So I found it quite fascinating.
So basically, nobody saw the moon before, during, or after the eclipse.
That's correct. In my opinion, yeah.
So the conclusion would be that the moon didn't cause the eclipse. That would be the logical conclusion, right?
That's my logical conclusion. Yeah, it wasn't observed. Now, it's not to say that the moon during its phase of new moon isn't in the proximity of the sun and or behind it or somewhere else in the same field, right? And both are being occulted, right? Because we know the new moon phase is being occulted during the new moon. It just, once a month it does it. That's a natural thing. So the difference is that the moon would pass through that cancellation field, every month, but the sun only does it, 3-4 times a year, right? So the constant is that there is something that is interfering with the light of both objects, right? A new moon is essentially a solar eclipse. It happens once a month. Right. The phases of the moon is a perpetual eclipse. It just phases in and out of eclipse phase, right? It just never stops. But the sun only hits that point, 4 times a year. It's just a different path of the light. Right.
So could the sun be acting like the moon's phases, just only several times a year?
Yep, that's what I'm thinking. Yep, exactly the same thing. So whatever's causing that it's consistent with both, but it's independent, right?
Yeah, makes sense. I mean,
yeah.
With those photographs we all saw now, it kind of makes sense.
Yeah.
And what about I was thinking about the meteor craters, which are obviously not caused by any rocks from outer space. So
yeah.
Could it have something to do with this electromagnetic force and with their lunar craters that we see?
You mean is there a tie-in between the craters on the moon and the craters on Earth? Is that what you mean?
Yes. Could they be caused from a electromagnetic force acting under the Earth somehow?
Oh yeah, absolutely. Yes, that's exactly what it is. In my opinion, it's the majority of the craters on Earth are caused by electromagnetic strikes and the cataclysmic type of arcing out. And it's quite possible that at one point in history, ancient history, the moon was actually involved in a huge electromagnetic storm, shorting out to the Earth's surface. Absolutely. That's, people want to kind of look into that theory and stuff and how that actually works is I recommend the Electric Universe websites, and there's 20 years worth of research there. But the interesting part is you can't find that on Wikipedia. It's actually a banned topic on Wikipedia. So the mainstream is not allowing anyone, or they're trying to stop people from looking at the Electric Universe theory because it backs all this up 100%. And even though the Electric Universe, I think the majority of those people that are studying, because they're all PhD electric, physicists and plasma physicists, and it's really high-end stuff. But the majority of those people aren't flat earthers. But the foundational principles upon which the Electric Universe theory is built is exactly this principle, right? It's a dielectric field. We're in a dielectric circuit, and we're in a capacitance type of process between the two. There's a charge differential. As above, so below, but it's inverted, and it's just backward.
Yeah, it kind of makes sense. And also that, I find interesting the meteors that, the only thing we see are some lights crossing across the sky. We've never observed, there's no footage of any rock of any kind. So I think the meteors could be electromagnetic or electric phenomenons happening maybe in the dome or whatever you want to call it.
Yeah, the way I see that is if there was a crystal lattice type or a crystal, even if it's semi-plastic or fluid, like when we look at the Cola 8 project, which it drilled into the Earth's surface for, I don't have any pictures of it, but you can look it up. The Cola 8 project drilled as deep as it could go for 20 years straight. The drill ran 24/7, 365 days a year for 20 years. And it never drilled any deeper, I think, than 12 kilometers or 8 miles roughly. It couldn't get through a barrier at that level. Because when I looked at the reports, when I was in the mining industry, I used to work in it, that was my profession. When I looked into it, what that is there's a layer down there that is actually a super plastic. It's like a superfluid, but it's under such pressure that it's hydrogen and water and carbon is the main primary ingredients in it. And it's under such pressure that the hydrogen atoms and molecules actually become like a metal. It's under such pressure that the hydrogen goes from a gas state into a plasma state, more or less, and straight into a metal. But it remains plastic.
Chris,
because